All right, let's talk about binomial probabilities. This is lesson 6.2. We're going to talk about what a binomial model is and when it's appropriate, and then we're going to calculate that probability using a binomial model in a lot of different ways. So let's start with just a kind of pre-example, just to introduce the idea of what this is all about. So suppose that M&M's company decided to cover 30% of their M&Ms in speckles. So instead of just like plain colors, they're now speckled. You buy a very large bag of M&Ms and remove candies one at a time, looking for an M&M with speckles in it. So firstly, just look through a couple basic probabilities. So what's the probability that you get a speckled M&M 3 times in a row? So that would mean probability that we get a speckled and another speckled. Okay, so if we think about our rule for and that we learned last unit, our rule for and is that we multiply. The probability of getting a speckled M&M is 30% or zero point 0.3. So we would multiply zero point 0.3 times 0.3 times 0.3, which gives me 0.027. Secondly, what's the probability that we don't get a speckled candy until our third pick? So that would mean we get not speckled, and then finally on the third one, we get a speckled. So not speckled and not speckled and speckled. So again, we multiply. If the probability of a speckled M&M is 30% or zero point 0.3, we know the probability of not getting a speckled M&M would be 1 minus 0.3, which is 0.7. So 0.7 times 0.7 times 0.3, which gives me 0.147. So then our third question, and this is going to kind of lead us into what we're actually learning in this unit. What is the probability that one of the first 3 candies is speckled? One of the first 3. Well, that one's a little bit trickier because there are different ways that could happen, right? We could get a speckled M&M first and not the other 2, etc. So the first thing we have to do, right, is we're going to start with what are the different ways that this could happen? What are the possibilities for this occurrence? Just that 1 out of 3 is speckled. So one thing that could happen is we get a speckled one first, and then we get not and not. Second thing that could happen is we get a not speckled one first, and then a speckled one second, and then a not speckled one third. And the third way that this could happen is we get 2 non-speckled in a row, and then on the third one we get a speckled, right? So we just want 1 out of 3, but that can happen in 3 different ways. And technically, in terms of probability, those are all different calculations. Those 3 occurrences are different calculations. So to get the overall probability that 1 of 3 is speckled, we have to account for all of those occurrences. We have to add those probabilities together to get that overall probability. So let's do that. What are the probabilities for each of those occurrences? So probability of a speckled one first and then not and not would be 0.3, because 0.3 is speckled, times 0.7 would be not speckled, times 0.7 again, which is 0.147. For the second thing, not and speckled and not, would be 0.7, 0.3, 0.7, which is 0.147. And then not and speckled would be 0.7, 0.7, 0.3, which is also 0.147. We add those all together, 0.147 plus 0.147 plus 0.147, and we get our final answer, which is 0.441. Right. Okay, so we got the answer. We accounted for all the different possibilities. Let's do the same thing. What if there were 2? We wanted the probability that 2 out of the 3 candies is speckled. So again, we have to think of the options and find the probabilities. So one option is we get speckled, speckled, not. There's that probability. Second option is we get not speckled, speckled. And then the third option is we get speckled, not speckled. We add all those together, we get our answer. So we kind of see that rhythm. We have to think of what are all the options for getting this amount, and then what are the probabilities of each option, and then we add them all together. You might start seeing some patterns, like for example, all 3 of our options for this one had the actual same probability, and the same thing happened on the previous one. We just had to know how many options there were. So there are ways to make this a little bit shorter. So just to kind of show you an example of one where we wouldn't want to do it that long way, if I asked you what's the probability that 10 of the first 50 candies, not candles, is speckled? Well, that's a whole lot more, right? There's a lot of different ways that 10 out of 50 could be the first 10 and not the last 40. I mean, there's so many different possibilities that it would take me forever to just figure that out, let alone the probability. So we really don't want to have to do this the long way. So we're going to talk about a shortcut, right? This is all about working smarter and not harder. So that is where the binomial distribution comes in. The binomial distribution is in a situation where if we know the probability of something happening once, or like with the M&Ms, we know what that overall percentage of speckled M&Ms is, and we want to know the probability that it happens a certain number of times. That is when we use a binomial distribution. There are 4 rules to a binomial distribution. So in other words, in order to use this kind of model and to use this shortcut for probability, there are 4 things that have to be true. The first thing is that we have to have a fixed number of trials, right? So we have to be saying, I'm going to pick 10 M&Ms, I'm going to pick 20 M&Ms. It has to be a set fixed number of trials. We can't just say like, oh, I'm going to go until this happens. We have to have a set number of trials. Second thing is that each trial is independent and repeated under identical conditions. So when we pick M&Ms, we have to have an idea that the first M&M is not affecting the second one, etc. The third thing that has to be true is that each trial only has 2 outcomes. We have to be measuring success versus failure. Is the M&M speckled or is it not? We couldn't do this if we were talking about like what are all the 6 different colors of M&Ms, right? We have to be looking at yes or no, speckled or not, success or failure. And then our last rule is that for each trial, the probability of success stays the same. So we can't have that difference in the probabilities. So let's look at a couple of examples where you have some scenarios. We're going to decide, can we use a binomial distribution for these scenarios? So first one, you play a game with a friend where you each spin a spinner until one of you lands on red. What is the probability that you will land on red before your friend? So we just want to know, we're not going to answer this question, but we want to know, what is this binomial or not? Could this work with that binomial distribution or not? For this one, it's not, right? We don't have a set number of trials here. We didn't say, I'm going to spin the spinner 10 times, so what's the probability that I land on red 5 times, whatever. So we don't have a set number of trials, so that would not work for binomial. Part B, you answer a 10-question multiple choice quiz. Some of the questions have 4 choices, some of them have 5 choices. What's the probability that you get 7 correct? So we do have a set number of trials, and we're trying to find the probability of getting a certain number of successes. We are measuring success versus failure. We get it right or we get it wrong. The problem is that the probability of getting a question right isn't the same every time. If some of the questions have 4 choices and some have 5, right? For the 4 choice ones, I have a 1 in 4 chance of getting it right. For the 5 choice ones, I have a 1 in 5 chance of getting it right. So my probability of success isn't the same, so that wouldn't work either. Part C, we flip a coin 5 times. What's the probability that we land on heads 3 times? So again, we have a set number of trials. We're flipping it 5 times. We're measuring success versus failure. Do we land on heads or do we not? Probability when we flip a coin, that stays independent and it stays the same the whole time. It's always a 0.5 chance of getting on heads. So this one seems good. It passes all of our rules. And then part D, you roll a 6-sided die, 60 times, a fair 6-sided die 60 times. What's the probability that you land on, or that you roll exactly 10 of each number? Right, so this one, we have a set number of trials. The problem is we're not really measuring success versus failure. We're measuring how many times I get a 1, 2, 3, 4, 5, and 6. In order for this to be with a dice, in order for that to be a binomial, we would have to say something like, how many times do I land on 6? So I'd be measuring, did I land on 6 or did I not land on 6? It has to be 2 outcomes. So let's look at an example of how we would apply the binomial model to do a little bit of a shortcut. So suppose you play a game where you spin the spinner 10 times. You win if you spin red exactly 2 times. So it has to be exactly 2 times, and you have to spin the spinner 10 times. So that's what makes it binomial. We have that set number of trials. We're measuring the probability of getting red or not red, and we're finding that a certain number of trials. So step 1 is to figure out how many different ways are there of getting 2 reds out of 10. So remember, I could get the first 2 and not the last 8. I could get not the last 8, but get red on the last 2. There's a lot of different ways that could happen, and I need to figure that out. How many ways, how many different possibilities are there of getting 2 reds out of 10? So instead of having to sit here and think of all of the different ways, I am going to use a website. You can use a calculator, which I can show you in class next time if you are curious, or you may remember it from another class. But Google is amazing. So if I just type 10, choose 2, right? 10 means that we're spinning the spinner 10 times. Is this a spinner question? Yeah. Forgot all of a sudden. And then we want choose 2, meaning we want 2 of them to be red. So if I type 10, choose 2 and push enter, Google will tell you that there are 45 different ways that can happen, which is really handy. So we know that there are 45 different ways that I could get 2 reds out of 10. Again, the first 2, not the last 8, the first and the third, and not anything else. Like there's all these different ways. Calculator just told us there are 45. So now that we know that, the next step would be to find, well, what's just the probability, just using our basic probability rules, of getting 2 reds and 8 not reds. So if we think back to last unit, this is an and. We want red and not red, not red, not red, not red, not red 8 times. So I'm just going to multiply. And if I'm multiplying repeated times, we can look at that as putting in an exponent. So 0.25 squared, meaning we multiply 0.25 times itself. Where did 0.25 come from? Well, the probability of getting red on my spinner is 0.25. There's 1 out of 4 that are red. So 0.25 squared multiplied by itself because we want 2 reds. And then we want 8 that are not red, right? Not red would be the rest of the circle. So 0.75 would be that probability. And we multiply that by itself 8 times because we want it to happen 8 times in a row. So we want 2 reds and 8 not reds. We put that in our calculator and we get 0.0063. So then where I'm going to get that probability is I'm going to take the number of different ways that there were of that happening, which was 45, and I'm going to multiply it by that probability that I got in part 2, which gives me 0.2816. So there is a way to do it. Now you may be wondering, you said this was a shortcut. This doesn't feel like a shortcut. This still feels like a lot of work. But a little bit shorter than what I did a little bit earlier with the speckled M&Ms, but it's still not like that short. Don't worry, there are quicker ways to do this, which I'm going to get to in a little bit. Okay, I'm going to do one more example. If I wanted to get red exactly 3 times, what's the probability that you win the game now? So step 1, how many different ways are there of getting 3 reds out of 10? So again, if I go to Google and I say 10, choose 3, it would tell me that there are 120 different combinations or different ways for that to happen. Step 2, what's the probability of getting 3 reds and 7 not reds? So again, I want red and red and red, and not red, not red, not red, not red, etc. 7 times. So again, I would do 0.25 to the 3, and then 0.75 to the 7, which gives me 0.0021. And then I multiply my number of ways times that probability. So now I'm going to show you kind of one of our shortcuts. So there's going to be 2 different shortcuts I'm going to show you in this lesson today, but I'm going to show you this first one. So if I want to do the shorter shortcut in the calculator, okay, the directions are on the screen, so I'll go back to that screen in a second. So if you want to like screenshot it or write them down or pause it or whatever, you can. The way I do this is I'm going to push the second button on my calculator, and I'm going to click this button that says VARs, which is kind of right underneath the arrows. Then I'm going to scroll up. I'm looking for the word binom for binomial, and they're towards the bottom, so I like to scroll up. And you'll see we have 2 options. Right now we're going to use binom PDF, and we'll talk about the difference between those 2 later. It asks for 3 things. It wants the trials, which in this case would be the number of times we spin the spinner, which is 10. It asks for P, which is our probability of success. In this case, what's the probability that we land on red, which was 1 out of 4, or 0.25. Fun fact, if you type 1 divided by 4, your calculator is cool with that. It'll figure it out. And then X value means how many times do we want it to land on red. In this case, we want to find the probability that it lands on red 3 times. So I'm going to put a 3 for my X value. Then I hit paste, and then I'm going to hit enter. And I get 0.2503. Same answer that I got when I did it by hand, which is really handy. So that is how we use the calculator. I promised you I would pause here for a second, so I'm going to pause. I'm going to look really cool. So if you want to pause and then write some of those steps down, you totally can. But let's look at another example. So we're going to talk about Among Us again. So in every game of Among Us, you have a 20% chance of being the imposter. Suppose you play the game 20 times. What is the probability that you're the imposter at most 5 times? At most 5 times. So firstly, what does at most 5 mean? We have to think about what is at most 5. So at most 5 would mean that you get imposter 5 or fewer times, meaning 5 or 4 or 3 or 2 or 1 or 0 times out of the 20 times you play the game. If I wanted to do this by hand, right, using kind of that process, the step 1, 2, 3 that I did before, it would be pretty complicated. I would first have to find what's the probability of getting imposter exactly 0 times, what's the probability of getting imposter exactly 1 time, and then 2 times, and then 3 times, and then 4 times, and then 5 times, and then I would add all those probabilities together. And I can use my calculator shortcut, that Binomial PDF that I just talked about, but even then, I would have to do that for 5 or 4 or 3 or 2 or 1 or 0, and then add them all together. So it can still be a little bit long, and our shortcut has now suddenly turned into, that's a bit much. So, too much work, I have stress ulcer, we're gonna do something else. Right, so there's another option in our calculator, you probably saw it. It is called Binomial CDF. Binomial CDF is for when we want less than or equal to a certain number. In this case, I want at most 5, which means less than or equal to 5 imposters. So that's when I would use Binomial CDF. It's a similar process as what we did before. We're just picking a different option. Oops, I clicked alpha instead of. So second bars, I'm going to scroll up and go to Binomial CDF, which is the B choice. It asks for the same 3 things. So trials is still how many times? In this case, we are playing the game 20 times. I almost put 10. And then P is the probability that we get imposter, which they told us was 20% or 0.2. And then it wants the X value. The X value would mean, remember, this is less than or equal to. So the X value is what do we want less than or equal to, which in this case is 5. Because I want to get imposter 5 or fewer times. Then I go down to paste, push enter again, and there's my probability. So again, I'll pause here for a second if you want to look at that. So similar steps, we're just choosing a different option. All right, so the probability of getting imposter at most 5 times, 5 or fewer times, is 0.804. So it's pretty likely. It's pretty likely that you'll get imposter 5 or fewer times if you play it 20 times. So let's talk about the difference real quick between Binomial PDF and Binomial CDF, because obviously it can be easy to confuse the two in your calculator. So Binomial PDF is when we're finding the probability of exactly a certain number of successes. So if I had said, what's the probability I get imposter exactly 5 times? You can think of the P in PDF as for perfect or precise. We want a precise, perfect, exact number of successes. Binomial CDF is when we're finding the probability of less than or equal to a certain number of successes. Sometimes it'll be worded as at most. Okay, but we can think of the C as for cumulative. So cumulative means kind of everything up to and including a certain value. So that's what we're doing here. We're doing everything up to and including a certain number of successes. So at most 5 would be an example of this type. Okay. So let's look at one more example, and I'm going to show you another way or another shortcut that we have besides using the calculator. So this will be good for those of you that maybe don't have a calculator or just want a different way of doing it. So suppose we take a 10-question multiple choice quiz where each question has 5 choices. You want to find out what your chances are of passing the quiz by just guessing randomly on every question. What is the probability that you pass? So firstly, let's think about how many questions do I need to get correct to pass? So that would be 7 or more, right? So 7, 8, 9, or 10 questions right would give me a passing grade. If I wanted to do this by hand, right, I would have to find the probability of getting exactly 7 right, find the probability of getting exactly 8 right, and then 9, and then 10, and then add them together. If I want to use the shortcut in my calculator that Binomial PDF, with Binomial PDF is perfect and precise, I would have to do that separately for 7, 8, 9, 10, and add them all together. Can I use binom CDF? Kind of, but we kind of have to work backwards or think backwards. Remember that binom CDF, cumulative, is less than or equal to a certain number of successes. In this case, I want more than. And there is a way to work around it, which I'm going to leave on the screen for a second. But to be honest, it's something that we don't necessarily want to have to do it this way. You can do it this way, but I want to show you a website that we can use that kind of just makes this a little bit easier, right? So this whole idea is that we're kind of working backwards. Okay, one thing I did want to point out, we're talking about passing a quiz. There were 5 answer choices on each. It said that each question has 5 answer choices. So when I talk about my probability of success, probability of getting a question right would be 1 out of 5 or 0.2. Right, so this would be a way that I can still use my calculator and still use binom CDF to find this probability of getting 7 or more questions right. It's all a matter of kind of working backwards and thinking about what I don't want and then subtracting it from 1. But let's talk about an even nicer way of figuring out that probability. So kind of working backwards, using my calculator to find what I don't want, subtracting from 1, I'm going to get 0.0009 or 0.09%. But let's talk about a lovely website. So again, I'm going to have this on the screen if you want to screenshot it so you have the instructions, but I'm going to go through it as well. There is a website through Staplet. This is the same website that we've been using, that we used last semester for like 1var stats and 2var stats and things like that. But they have one for binomial. And I have all the instructions on here and some pictures and stuff. But I want to go ahead and look at what this would look like. So staplet.com/binom.html is the website. Now it looks like this when you first go onto it. First thing I'm going to do is type in my n, which is the number of trials. In this case, I have a 10-question quiz, so my n is 10. B is the probability of success. In this case, there were 5 answer choices on each question, so my probability of getting a question right is 1 out of 5 or 0.2. And then I'm going to plot distribution. For today, for right now, I'm not really going to use the graph, but it is there in case you were curious. It kind of just tells us what's the probability of getting 0, 1, 2, 3, 4, 5, 6, etc. questions right. It also gives us a mean and standard deviation, which we don't need right now. Where we're going to focus on is this little area below. It says calculate the probability of. It says exactly right now, but I have the option to change that to less than, at most, at least, and more than. So in this one, I wanted to know what's the probability that I pass the quiz, which would mean the probability of getting at least 7 successes. Right? And then I click go, or even if I just click off of it, it kind of shows me the area of the graph that I'm dealing with, which I can see. I can't even see the bars, so it's a very small probability. But then it also gives me that probability right underneath the graph. It tells me in a percentage, it's 0.09%. So that was a lot quicker than trying to work things around in my calculator. It is always okay to use this website. You can also use it to find the probability of exactly 7 successes, less than 7 successes. I can kind of change around the numbers, and this just makes it a lot easier to figure out what you need, and it shows you visually what that probability is, which is really, really handy. So that is the website. So that is all I have for you today. We're going to talk more next class about how to deal with binomials, and we'll do some more practice. Have a good day.